So, without further ado, let's start. As Alexis said, the topic is realistic NPC dialogues and how we can make them better in this day and age with the use of modern LLM technologies such as ChatGPT and whatnot. So, there will be a little bit of memes throughout the presentation, so be prepared. We are all familiar with how NPC dialogues work right now in general. In current games, we are extremely used to it. We know what to expect. Yeah. Knowing what happened throughout the last year, throughout a year before that, how far did we go with the current technologies such as ChatGPT, most of us actually start thinking, hey, couldn't we apply some of that magic in the games? And of course, that thought has crossed many minds. A little bit about me, I have close to no relation to gaming in my day-to-day job. I actually work at a company called Dynatrace. We are a monitoring and observability company. We do a lot of enterprise type of monitoring, but we are heavily invested into AI. And that's why we are kind of considered experts in this field, in the industry. I've been a software engineer for close to a decade and worked throughout all this time with AI as well. And I'm an avid open source contributor, which involves some AI projects as well. So an agenda of today's talk is going to cover the following topics. We are going to do a quick review of what current NPC dialogue systems look like, what we all know. We will wonder and ponder the question whether we can use something like ChatGPT in them. We will cover how large language models work in general, and we will take a look at the demo. We will review a quick review of industry solutions, what current big gamers are proposing, gamers in the market, not gamers who are playing games. What are they proposing for us? And we will also review what kind of problems existing industry solutions have. A bit of latest research, maybe not a bit of, maybe a little bit of deep dive, depending on how much time we have. And next steps, what future holds for us. So let's jump into it. Current status quo. Either there are extremely primitive dialogue systems, or it's a gigantic tree of possible options, which is really hard to maintain, and it is very deterministic. All the dialogues are pre-coded, they are written, they are voiced, and then it all goes into the games. That's what we are all used to. And we try to push that boundary further, but there are limitations, of course. We try to maintain illusion of choice, as in many games, but implementation of that in games themselves is extremely difficult. So it's quite easy to become overwhelmed for game developers with trying to create realistic and free choice kind of dialogues. Yeah. So just a few examples with which I'm sure most of you are familiar with. A famous game called Facade. It's a 2005 game. It's actually a great example. It's a game developed by AI researchers who tried to create an AI-based game when AI was in its sort of adolescence stage. They implemented a parser and decision trees and everything which is considered part of the AI. So remember that even the simplest things, such as if-else, is actually formally considered to be part of AI. Machine learning is part of AI, but it wasn't that prominent in 2005. So the game is actually just a setting where you play as a friend who visits a couple who have marital problems, and you try to talk with them. They are on an edge of breakup, basically, so you can actually make it so that they reconvince and decide to continue their relationship. You can also force them to divorce, which is pretty cool. And there are no deterministic ways in the game, it looks like at least, to to drive the game. So there is a bit of random choice introduced in the gameplay itself. But there are, of course, interesting bugs. For example, the game can detect that you are speaking obscenities. For example, there is a word melon, like just a melon, right? If you write it down inside the game, it instantly throws you out, like, hey, get out, get the heck out of my apartment. That's because they hard-coded that certain words, curse words, including melons, which represent women's parts, cause you to instantly jump to the game end. So that's funny, and there are a lot of YouTube videos about it, but it was actually state-of-the-art back in 2015. Next case, Fallout 4. I think you all know what it's going to be. Does Fallout 4 has realistic dialogues? Well, I would say no. And we know how it progressed. Bethesda, they started quite well, then it got worse, and now we are somewhere here. Not really realistic. Part of it is to blame on Bethesda themselves. Part of it is to blame on lack of developments in this field. One other example I wanted to give is Detroit Become Human, famous game from Quantic Dreams. They are very heavy into story-driven games. For example, Heavy Rain is their production as well. So in this game, you can learn certain events and use them in your dialogues. And the game is famous for a gigantic tree of options. It's quite an achievement. They invested a lot during game development to make it as replayable as possible, but the dialogues interface itself is quite simple. You don't choose dialogue, you choose a word which represents the dialogue option, which is not exactly what we try to achieve. But it worked pretty well. There is this famous scene in the game where you have to convince a robot to release a hostage. And it has a lot of choices in it. And it would be amazing if we could actually talk to that NPC and try to convince it with our own words. How far could we go? Could we actually release the hostage? So that's what we try to achieve. And currently, this is all implemented like that. So gigantic trees, which are hard to maintain. Every game engine comes with its own implementations. There are countless plugins, and it's easy to get lost, and it's really hard to maintain. I'm not sure if it's visible on this picture, but there are countless lines connecting each option. Imagine how hard it is to code all of that. So can we achieve realistic dialogues? Well, of course, let's just plug ChatGPT in and here we go. We are ready to release. Well, not so fast. I beg to differ. Let's talk a little bit about what ChatGPT is. So it's actually a thing called transformer. Not this one, and not this one as well. It's actually a white paper released by Google in 2017. It's Google's invention. They were trying to solve a problem of translation, non-deterministic translation, statistics-based translation. Let's not care about grammar and everything. Let's just take a piece of text and map it to another piece of text. Let's try to predict what the translation will be. And then they had an amazing idea. Let's translate English to English. Like, what the heck? But it was actually a great idea. And they created a very scalable architecture of a machine learning model. This architecture could be trained on gigantic clusters of GPUs and with gigantic corpuses of texts. So essentially, you feed large language model with a large corpus of texts. Some of the first language models were trained on Reddit, for example. And then you can fine-tune it, and then you can just feed it a sentence, a quick brown fox, and then large language model determines what is the most likely next word in the sequence. And in this case, the most likely word is fox, because The quick brown fox jumps over something something is a very famous phrase in a training data. What LLMs can be used for right now? So they can be used for sentence completion, question answering, summarization of text, and even role play. How does it look like? You basically give a prompt. Sherlock Holmes is a... What is Sherlock Holmes? And it gives you a reply, because this is a most likely continuation of that sentence. Sherlock Holmes is a private detective, and so on and so on. How do we prompt the large language model properly so that it behaves the way we expect it to? Well, there are already some existing solutions. First one I want to mention is a thing called Tavern AI. It's an open source project which basically helps non-specialist people to prompt the large language model in such a way that it behaves in a role-play fashion. The way it looks like is that you give certain settings, you give a system prompt, hey, you are a fictional character, and so on and so on. You specify randomness of generation, which is a parameter called temperature. And you can specify a lot of things, like how large should the reply be. Here's an example of how to code Todd Howard. You can just give examples of conversation, you can specify a scenario, you can give a description of characters. All of this was actually determined by sheer experiment. No one knew before last year how to properly prompt a large language model. This was done through sheer experimentation, and people found out that this kind of format works the best. So how about we just try to talk to Todd a little bit, a small example. So I have Todd online with me right now. He tries to pitch me Starfield. And instead I ask, can you fix bugs in Fallout 76 instead? Let's see what Todd replies. Bugs? Yeah, there are no bugs. By the way, have you heard about Starfield? And he answers that way because I prompted the model to behave like him. And my prompt is very small. The actual prompts to create realistic characters could be pages long, but there are certain limitations to how big of a prompt you can create. For example, this is what happens behind the scenes. There is a giant system prompt. There are some help prompts. So I use this kind of syntax because this is what OpenAI specifically, the creators of ChatGPT, that's what their model understands best. Other language models actually work better with different formats, but for ChatGPT and the OpenAI model behind it, this one is the best actually. So it's very simple actually, there is no magic, it's just prompting at this moment. Yeah, exactly what I showed. And here is my reply, and then the model gets all that and generates the most possible continuation of the conversation. Do we have any industry solutions? Yes, we do. There is a very old, several years old company called Character AI. They are very chatbot oriented. We can't really use them in games, but there are different solutions. For example, in World, they are currently, I would say, state of the art. Very well programmed solution can be integrated into games right away. But behind the scenes, let me tell you, all of the industry solutions are exactly the same. They are exactly the same as Tavern AI. It's just prompting. Everything is stored inside the prompt. For example, here is Canva AI, very similar solution. You can see that player talks to an NPC, hey, pick up a shotgun. Yes, of course, I will go and do it. Sounds plausible, but not quite realistic. And of course, there is NVIDIA, but I wouldn't consider them as a real solution. They are heavily focused on making large language models run on your NVIDIA GPU. So they are not interested in making it easier for game developers. They are interested in selling more GPUs. So I wouldn't consider them as a real solution. What are the problems with existing implementations? It's just Tavern AI all over the place. We can't put everything, including information about the world, into a single prompt. Like, how do we put entire lore of Witcher games into a single prompt? That's not going to happen because prompts are limited. Each large language model is limited by its context size. Current biggest context for OpenAI is 100K characters. And for state-of-the-art models, such as Google's Gemini, whatever it is, it's 1 million tokens. But it's always going to be limited. There is no way we can put months of the conversation into the context and then hope for the better. No, that's not going to work. With this technique, the models lose the thread of the conversation. They forget what you said at the beginning, which is unacceptable if we want a deterministic outcome. They are unpredictable. You never know what they are going to generate. Well, you can expect it to generate something, but there is no way to tell what. Not very realistic and no states. There is no way to jump from the beginning of a conversation deterministically to the end of the conversation where we reach, for example, a desired state. What kind of current research we have? So I'll skim through it because we don't have that much time. Retrieval augmented generation, that's basically where you offload all the information about the world and current state into some kind of database right there at the top right corner. So when you generate a prompt, you retrieve the most relevant pieces of information from the database and put it into your prompt just for this single message. And that works really well. It works because of embeddings. Embeddings is a technology in machine learning to transform a text string into an array of numbers. And based on that, you can compare two arrays. So if you say, I want to find an information about Striga from the lore of Witcher, you can do that thanks to embeddings. Very good search technology. There are other approaches such as agents. Agents basically implement step-by-step thinking. So it's a lot of back and forth before the model gives you answer. Works better, but still not perfect. The current state of art in prompting is, let me show you like a basic example, right? You give a question, it answers incorrectly. You can improve it. Let's add some kind of reasoning into the initial question, and then it responds a little bit better. But then you can improve it even further. What if we allow model to chat with itself, to evaluate its own answer to determine whether the initial answer it gave is correct? And that works much better. So for example, here in this final example, in this research, the model concludes with a proper answer to the question, even though it couldn't do it, the same model couldn't do it at the very beginning. What other tools do we have with large language models? Well, we can fine-tune them. This is a fancy word, but fine-tuning is not enhancing the model. We are just teaching it to reply in a very specific format. That's it. Fine-tuning doesn't bring any new knowledge into the model. LoRa is a different technique. You can train very small addition to the model, which can be merged with the base model, and then it gets information about, for example, your game world. Text enrichment. You have a you have a pre-coded, hard-coded piece of text, and you just ask large language model to format it to look better for this game situation. So, for example, the quick brown fox jumps could be enriched into, hey, I have to tell you about the quick brown fox that jumps. So, good solution, but only partial. And finally, what are the next steps? So it's all good, right? We can't really use it. It's kind of in the middle somewhere. What does the future hold? Where is it all going? Well, the proper solution, in my opinion, would be to merge the large language models with old software engineering techniques and natural language processing techniques known to software engineers since the 80s. For example, dependency parsing in sentences. This is basically when we parse a sentence, such as, I like games, do you? There are already solutions which are a decade old, which are capable of parsing such statements into individual tokens. We can use that result to build a world model. For example, Todd likes games, and Todd went to a conference. We can then store this information in a graph database and use that graph database to retrieve current information about the world during generation of the sentences. So for example, your character, your NPC, could first be in the idle state, it's ready to talk, and there is a special prompt which covers that. Then you do something, you cause a trigger, like, hey, I want to talk to you. And the game detects that, hey, the player wants to engage with me, so I'm switching to the different states called interested. And this state has a completely different prompt. So the character starts to behave differently. It wants to talk to you. It replies differently. Then you switch to a next state, such as goal reached. Maybe the character gave you a key to some room. There is no way to get back from goal reached to the idle state. So it solves the problem of characters being unpredictable. Once you got the key, that's it. The prompt doesn't allow the character to switch to any kind of different conversational state. Of course, there are different states. Maybe you said something and the character doesn't want to talk to you anymore. Or maybe you said, hey, to heck with you, and the character won't even acknowledge you after this. Each state is controlled by its own prompt, and the switching between states is controlled by the triggers. So in my opinion, that would be the solution for the future. A little bit about what you can do right now before the future comes to us, right? Before it's all available for game developers. Well, you can use OpenAI for lore generation, for example. I really recommend it. It's really good at it. But remember, good prompt is everything. And also don't use ChatGPT. ChatGPT is extremely limited. Instead, use proper API. Give it a gigantic prompt. The bigger the prompt, the more detailed it is, the better. So you can already generate a lot of value just by using existing API. Also, you can do very nice automatic translations. It's the best translation system in the world currently. You can already use some on-device models, such as Pygmalion, Gemini, and Llama CPP, an honorable mention. This is how you actually run the models, even on CPU or on GPU. Works really well, works with Unreal Engine, works with Unity. So you can already run this stuff, even if your gamers, if your users do not have real GPUs. It works. And of course, if you don't want to rely on on-device models, you can use existing APIs, so OpenAI, Mistral, and Google, GCP. But that, of course, requires internet connection. And that's it. I have some contacts here. If you have additional questions after the conference, please don't hesitate to reach out. I'm always open to talk about these topics. And hopefully, me and all of you we are looking forward to what next year and next decade brings to us in terms of these developments. Thank you.
Much. It was really very interesting as for me. And we have time for one, maybe two questions. Yes, we have one question.
So the question is from kind of another perspective. So you've been talking like we can teach, we can train the model, we can like use specific wording and etc. But all this comes to one thing, that a user can prompt anything. Okay, you can limit like the answers. But for example, you like prompt them, go get a gun, but there is no guns in the game, for example. Right? So every kind of answer that this language model that can answer and like try to do, if you can, I mean, all this is like if you can do trying to tie it to gameplay, right? You can go and do something.
Yeah.
So basically you need to program this behavior for every possible outcome that you train upon, right?
Almost. So if you already have a game state saved somewhere and it is serializable into some kind of text, even JSON, a description of every object in the scene, where it is it there, is it not, you can feed it. And that's actually why, let me see, why this technique exists. That's basically a technique to solve a benchmark for large language models. And that benchmark is called real world, AF real world. This benchmark is actually a text-based game where the task for LLM is to go and pick up a cup from the shelf and make a coffee. And it gets a JSON where there is information where the cup is, where the coffee is, what is not on the scene, and so on. And the model uses the reasoning to correctly figure out steps. Go 3 steps forward, go 2 steps left, pick up the cup, and so on, and it works. So you don't need to necessarily program it. You need to give it a state and use a technique to make it more predictable.
Yeah, so basically you limited by like the things that you like gameplay things that you have in your game, and that's it. It's prompts will be different,
yeah,
but outcome is the same.
Yeah, but it's more flexible, it's more replayable. So there is almost no chance to get the same
it's like
kind of dialogue.
Kind of paraphrasing, like every replay will be like kind of different dialogue, but outcome is the same.
Yeah, more or less. Yeah.
Thank you very much. We have no time, unfortunately, for another questions, but don't hesitate to reach out, Vagiz, here or there or anywhere, I don't know. Thank you very much. It was very useful, very interesting.
Thank you.
Have a nice conference, guys.